Yes. Good afternoon, girls. Today's class is again a second lecture on spheres. I'm going to start the class. This is again sphere, girls. Can you all see the document, girls? Yes.
Yes,
Yeah.
ma'am.
Yes,
See,
ma'am.
yeah, this is second lecture on sphere, girls. Kindly listen to me carefully with all diagrams. I'm going to explain to you once again in a brief way as what is discussed in the previous lecture. So, see sphere. You know, this looks like a circle when we draw it here, girls. Even on in the examination also, you cannot draw three-dimensional figures. That's why again, like how I did in the class, I'm drawing here like this. It appears to be circle, but you take it as a sphere. So now this is the sphere, girls, and you know AB is the diameter and the C is the center, and you take any point on this circle means all these points. This is the locus of all the points which are at a same distance from the center. That's why this CP is radius. Okay. Now you see the very first equation of the sphere. If you are given a center and if you are given radius means center the point C and radius means the distance CP, you can simply substitute in this equation to get the equation of the sphere. Okay, so if you know the center of the sphere and radius of the sphere, by using this formula you can find out the equation of the sphere. And when you expand this equation, you will get this general equation of the sphere, which is in the form x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Okay, so once you know the center of a sphere radius, by using this formula, you will get the equation of the sphere after expanding this. And sometimes, no, you will be given a general equation of the sphere like this, then in you will be asked to find out its center and radius. So here center and radius were given, and using this formula of finding out the equation of the sphere. Now if you were given an equation of the sphere, you should be able to find out the center and radius. Such problems I gave you homework, you might have done. So now this is the general equation of the sphere whose center is minus u minus v minus w. Here 2u is the coefficient of x, 2v is the coefficient of y, 2w is the coefficient of z, and d is the constant term. So the center is based on the coefficient of x, coefficient of y, coefficient of z, and square root of u square plus v square plus w square minus d will give you the radius. Radius means here CP. Okay. Now, if at all the center is origin, when you put for x1 0, y1 0, z1 0, you will get this as the equation of the sphere whose center is origin and radius is r. So, if you know even the ends of the diameter, see AB here is the diameter. If you know the ends of the diameter, where A is known to you, B is known to you, then also you can find out the equation of the sphere by using this formula. See, A is say x1, y1, z1. The other end of the diameter B is say x2, y2, z2. Then using this formula, you can find out the equation of the sphere with A, B as ends of the diameter. Okay, so now two spheres are concentric if they have the same center, I said the other day. So here, girls, I told you already the radius is depending on u, v, w, z, whereas center is only in u, v, w. Okay, so when both the spheres are having the same center, see how the equation is same till the xyz terms, but only they are differing in constants. That is why two concentric spheres here, see in the diagonal, there are two spheres, one is in blue, other one is in red, and these two spheres are having the same center here. But whereas the first sphere, if you see the center is the radius is this much, whereas for second sphere the radius is this much. Okay, they differ only in their radii, but the center is the same. So two concentric spheres means you can write the equation all like up to the xyz terms the same. Only thing is you can take a different constant term. Now, other form of the sphere, it is intersect form of the sphere, girls. See here, this sphere is actually passing through A, B, C. See here, A is the x-intercept, B is the y-intercept, C is the z-intercept. Okay, so equation of the sphere passing through O also. O means origin here. O, passing through O, A, B, C is given by this. X square plus y square plus z square minus ax minus by minus cz is equal to 0, girls. You have to remember this as a formula whenever you come across with such technical words, and in doing the problems, immediately you can make use of this formula, girls. Like how to get this equation, we will come to know in a few minutes. Already I discussed this in the class and derived also. Again I'm going to do today, girls. Okay, the same formula you can write like this also. See, the equation of the sphere passing through O, A, B, C is this. See, A means it is a point on x-axis. Once it is a point on x-axis, its y-coordinate, z-coordinate is 0. And B is a point on y-axis. It is the y-intercept. So, being a point on y-axis, its x coordinate, z coordinates are 0. Now C is a point on the z axis. This being a point on the z axis, its x coordinate 0, y coordinate 0, and let us take the z coordinate as small c. Okay, so now the sphere is passing through 4 points. O, origin, A, B, C. So this is called as intersect form of the sphere, girls. Sometimes no, you may have to remember like this. Sometimes you can say in the intercepts where x is A is the x-intercept, B is the y-intercept, C is the z-intercept. In the last class, spheres first class, I explained to you all these formulas, girls. Today I'm explaining to you once again as a revision with the diagrams. Now, you are coming to the other part here, that is plane section of a sphere. Plane section of a sphere means when a plane intersects a sphere, you get a circle. That is called as plane section of a sphere. So, you have a circle. I'll show you here. See here, this is a sphere, girls. This is a sphere, you know, and this is the plane. When this plane intersects a sphere, you get a circle. See, like this is a circle, and this circle is called as the plane section of a sphere. Means when a plane and a sphere intersect, you get a circle. Now, if at all you are asked to find out equation of a sphere passing through this circle, means you can write the formula as s plus lambda pi is equal to 0, where s is equal to 0 is the sphere, pi is equal to 0 is the plane. When this sphere intersects with the plane, or when this plane intersects the sphere, you will get this as the circle. S is equal to 0 is equal to pi is the circle in the form like intersection of a sphere and a plane. So this is the equation of a circle, girls. And now you're going to find out a sphere. This is the sphere, girls, which is passing through the circle. S is equal to 0 is equal to pi. Here afterwards, we are writing equation of a circle, means it should be written like intersection of a sphere and a plane. So when a sphere S is equal to 0 intersects a plane pi is equal to 0, the resultant is a circle. S is equal to 0 is equal to pi. Now you are going to find out a sphere which is passing through the circle, means this is the equation. What formula you have to put? S plus lambda pi is equal to 0 is the equation of the sphere passing through the circle. S is equal to 0 is equal to pi. My appeal to all of you girls is that be thorough with every formula. By heart the formula right from the beginning till the end, so that you will be in touch with the technical words, and whenever you come across with such words, immediately you can apply this formula, girls. Okay, by heart them. Number of times I'm saying the same thing. In the class I gave you the formulas. Again I'm giving you here the formulas in the revision. Okay, now you have seen what a plane section of a sphere. And there are two sections like this kind of, no, like when a sphere is intersecting with a plane, you get a circle, and there are two different circles are there. One is the great circle, other one is the small circle. Now, when do you say that a circle is a great circle? See here, the sphere is intersected by a plane and you got a circle. Here you imagine, observe girls, this is the center of not only the sphere, it is also center of the circle. So when the circle is a great circle, remember the center of the sphere lies on the plane. That is the very first point. Okay, so To identify whether the circle is a great circle or a small circle, what you have to do is you please find out the center of the sphere, girls. And when the center of the sphere satisfies the equation of the plane, you can say that the circle is a great circle. Because here you can see in the picture that the center of the sphere is lying on the plane. Okay, now one more thing is, if it is a great circle, girls, the center of the sphere is same as the center of the circle. Also, the radius of the sphere is same as, this is the radius of the sphere, this is also radius of the sphere. The radius of the sphere is same as the radius of the circle. Okay, so this is what, if at all you are thinking about a great circle, means this picture comes to your brain. You must recall this picture, girls. Okay, so if a plane passes through the center of the sphere, then the plane section of the sphere is called great circle. And remember, if it is a great circle, the center and radius of the sphere, they are same as the center and radius of the circle. Now let us come to the small circle. Here you can see the difference between great circle and small circle. See here in great circle, the center of the sphere is lying on the plane. Whereas in great circle, see, this is the center of the sphere. Whereas this is the plane. The center of the sphere is not lying on the plane. Okay. So that is the difference, girls. And here small circle means, here you see the center of the sphere is different from the center of the circle. See, this is the center of the circle and this is the center of the sphere. Both are different in case of small circle. In case of great circle, the center of the sphere is same as the center of the circle. Now, here also plane is intersecting with a sphere and resultant is a circle, and this circle is a small circle because the center of the sphere is not lying on the plane, and moreover the center of the sphere is different from the center of the circle. And remember, girls, here I drew a line red in color. See, this is what this is called, the this is actually the length of the perpendicular from the center of the sphere to the plane, or you can say this point, which is the center of this circle, is the foot of this perpendicular drawn from the center of the sphere to the plane. I repeat, girls, the center of the circle here is nothing but the foot of the perpendicular drawn from the center of the sphere to the plane. So in case of small circle, you will get the center of the circle as the foot of the perpendicular from the center of the sphere to the plane. Already we discussed how to find out the foot of the perpendicular from a point to the plane when we were discussing the plane problems and line problems. Okay, so that is why I told you those problems are very important. Here also will be coming across with such problems. Okay, remember, if it is a great circle, center of the sphere is same as center of the circle. If it is small circle, center of the circle is the foot of the perpendicular drawn from the center of the sphere to the plane. Here the sphere center is different from circle center, and here center of the sphere is not lying on the plane. Now, oh, here I didn't complete. Now, two spheres, if they intersect, you get again a circle, girls. This is the circle. Okay, so you get circle not only a plane intersecting sphere. Also, when two spheres intersect, also you get a circle. So this is the circle, girls. When two spheres intersect, we get a circle. And one more thing is, here a line intersects a sphere at 2 points. See, here you have a sphere, girls. Imagine this as a sphere. It looks like a circle, girls. I told you we are not able to draw three-dimensional figures in the examination. So that is why I'm here also drawing only 2 dimensions. It looks like circle, but now you have to take it as a sphere. Now when you have a sphere and a line is intersecting a sphere, it will certainly intersect at 2 different points, A and B. This is what I gave you for homework. So you have to find out the points of intersection of a line and a sphere. Okay, so all these figures will clearly explain, will make you understand the concepts, girls, and it is very easy to follow once you understand the concept. Now let us come to the touching spheres. These problems I gave you already for homework. So how many of you have done correct? You can check again. Now see here we have two spheres, girls. You have seen now intersection of spheres, that is different. Now you are seeing the spheres touching. Okay, they may be, see, this is the first sphere in red, girls, and see its center is C1 and radius is R1. This is the distance, no, radius is R1. Whereas sphere in blue, if you take, this is a sphere whose center is C2 and whose radius is R2. Okay, now the sphere in red, the sphere in blue, they are touching, girls, and see at a point P. Okay, so this is the point at which both the spheres are touching. Now, if you see this in figure, you can identify that these two spheres are touching externally. Okay, but while doing the problem, how will you identify? I gave you homework now. So what you have to do is, for the first sphere, you find out the center and radius. For the second sphere, you find out the center and radius. In the first lecture, I discussed with the finding out centers and radius only. So after getting centers and radius, see first sphere center is C1, second sphere center is C2. You see the figure, girls, here the line joining the centers C1, C2. This is the line joining these two centers. You find out the distance between these 2 points C1, C2 by using the distance formula. Okay, so distance between C1, C2 you see, and also you know how to find out the radius of the first sphere, radius of the second sphere. So sum them up. Okay, if the sum of the radii is equal to distance between their centers, you see that figure in the figure, C1, C2 distance is same as R1 plus R2. When the sum of the radii is exactly equal to the distance between the centers of the spheres, then we say that the spheres touch externally. That can be seen in the figure, girls. So to do the problem, you must find out the center and radius of the first sphere, center and radius of the second sphere, and you find out the distance between the centers using distance formula, and then you check whether C1, C2, the distance between C1, C2 is equal to R1 plus R2. If at all C1, C2 distance is equal to R1 plus R2, those two spheres are touching externally. Okay, and in this case, this P is what? It is the division, no? It is dividing the line C1, C2 internally. When the spheres touch externally, P divides the line C1, C2 internally. So you can find out the point P also. Okay, you can find out the point P. How, girls? R2 x1 plus R1 x2 by R1 plus R2. R2 y1 plus R1 y2 by R1 plus R2. R2 Z1 plus R1 Z2 by R1 plus R2, because here P is the internal division. It is dividing the line C1, C2 internally. So the line C1, C2 is divided by P internally when the spheres touch externally. That can be viewed, seen in the figure. See, the line C1, C2 is divided by P, the point P, internally. Okay, so such problems only I gave you to do at home. Now let us come to, see, uh, touching, spheres touching internally. See, this figure is different from this figure. Now you see, girls, again you have two spheres, the sphere in red, the sphere in blue. Okay, and for the sphere in red, C1 is the center. For the sphere in blue, C2 is the center. Now you see the distance between the centers, if you see, only from here to here. Okay, now the radius of the first sphere is from C1 to P, girls. Okay, that is, and radius of the second sphere is from C2 to P. Okay, now see, it is different here. When they touch externally, it is C1, C2 is R1 plus R2. When they touch internally, C1, C2, if you see, it is R1 minus R2. See, this distance minus this distance. This distance C1P is R1. This distance C2P is R2. So we need only C1, C2. So C1, C2 is R1 minus R2. Here the sphere C1 is having bigger radius. So we are writing R1 minus R2. Sometimes you may have R2 minus R1 also. So distance is never negative. So that's why you have to write here modulus R1 minus R2. So we don't know which sphere has got bigger radius. Okay, as this in this example, C1 is a sphere with radius R1, C2 is a sphere with radius R2, and R1 is bigger than R2. So R1 minus R2 will give you R1 means C1P minus R2 means C2P gives you the distance between C1 C2. I repeat, C1P is R1, C2P is R2. So R1 minus R2 will give you the distance between C1 and C2. So if you are unable to get that C1 C2 is equal to R1 plus R2, then you have to check whether C1 C2 is R1 minus R2 or R2 minus R1. In this case, we say that the spheres touch internally. Now see here, when the spheres touch externally, the point of contact becomes the internal division, point of internal division. Okay, now here the point of contact P is at the end. No, P is see to the left side of P, both C1 C2 are lying, whereas here for the point P, C1 is on one side, C2 is on another side. When the spheres touch externally, P is the internal point of division, and for P, C1 C2 lie on either side, whereas when the spheres touch internally, P is the point of division of the line C1 C2, but for P both the points C1 C2 lie on one side. So this is the external division of the line C1 C2. When you extend C1 C2 only, you're getting P. Okay, so when it is the external touch, the point is internal division. When this is the internal touch, the point is the external division of the line C1 C2. That is what you have to understand while finding out the point of contact also. First thing is you must test whether the spheres touch externally or touch internally, and second stage is you will have to find out the point of touch contact or point of intersect, point of division of the line C1 C2. Here also point of division of the line C1 C2, or we can also say that P is the point at which the spheres are touching, point of contact. Okay, this is what we have done yesterday, I mean in the previous class, girls. Now this is about tangent line. See, you have a sphere, girls. You have a sphere. From a point outside the sphere, you draw a line touching the sphere, girls. Now here PQ is a line which touches the sphere at the point Q, girls. Okay, then this PQ line is called as tangent line. Okay, from a point outside the sphere, you are drawing a line which touches the sphere at a point, say Q, so that this PQ line is called as the tangent line. And you have a formula, girls. Find the length of the tangent from a point to the sphere. He will be giving you a sphere, girls, and he'll give you a point, and he'll ask you to find out the length of the tangent from a point to the sphere. So in that case, what you have to do? I told you, no, PQ line is the tangent line, no? So the length of the tangent means the distance between P to Q. Okay, so that is nothing but the formula root S11. I told you already in the notations what is S11. S11 means x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d. Okay, so you will be given a sphere, so in which you have to put the point x1, y1, z1, and you just square it, find the square root of it. You will get the length of the tangent. Such problems are one mark questions, girls, and we have done them while doing the second component. Now tangent line is okay. Now let us come to the tangent plane. See, girls, this is a sphere. Suppose on this sphere you take a point and draw a tangent line. So through that point you can draw many tangent lines. Okay, many tangent lines can be drawn. See, that I didn't draw here because you are dealing with a sphere and it's looking like a circle. That's why you'll be confused. See, you have a sphere and see here there is a point Q and this is a tangent line. Like that, through Q you can have one more tangent line. Like this, many tangent lines can be there which pass through the point Q, and the locus of all those tangent lines becomes a plane. Okay, see, through Q you just imagine a ball, girls, and there is a point on the ball. through that point you can draw many lines which are tangent lines to the sphere at that point. Okay, so like imagine like that, girls. Through, if you have a ball, a sphere, and you imagine a point on the sphere, and through that point you draw many lines, girls. Many lines can be drawn to that point which are tangent lines to the sphere, and the locus of all those lines, you imagine it would be a plane. That plane is called as tangent plane. Okay, now this is the equation of the tangent plane again. X1 plus y1 plus z1 plus u into x plus x1 plus v into y plus y1 plus w into z plus z1 plus d is equal to 0. So equation of the tangent plane, how to find out? If you know the sphere and if you know the point, then you can find out the equation of the tangent plane using this formula. This is S1. This is S1. Okay. Now, two spheres will have a common tangent plane, girls. Okay. So in that case, S is equal to 0. S dash is equal to 0. Two spheres means S minus S dash is equal to 0 will give you the common tangent plane. Okay. Now, so far you have seen a sphere intersected by a plane. Sphere intersected by a plane. Now you are going to see today sphere touching a plane. Okay, so here see the figure how I draw. See here, this is a sphere, a plane is touching. Imagine, girls, you put a ball on a plank. Okay, put a ball on a plank. That is what sphere touching a plane. Okay, a sphere touching a plane means it will touch a plane at a point. See, that is what, if you draw the figure, it will be like this. Okay, so what is the condition for a sphere to touch a plane? That is what you are seeing. One more formula. So here, if you see CP means it is the radius of the sphere. Okay, and you know the radius of the sphere formula is this. Okay, what is this point P, girls? It is the point at which sphere is touching the plane. Okay, so when you put a ball on a plank, the sphere, ball, plank means plane, it touches at a point. That point is P. So CP is the radius of the sphere, and not only the radius, girls, it is the distance of the plane. Distance of the plane from the center of the sphere. Okay, already you have seen how to find out distance of a plane from a point. This is what the formula. Distance is modulus. Here the center means minus u minus v minus w. So ax1 plus by1 plus zz1 plus d by root of a square plus b square plus c square. So when you say that, when do you say that a sphere touches a plane? A sphere S is equal to 0 touches a plane pi if the distance of the plane from the center of the sphere, this is the distance of the plane from the center of the sphere, is exactly equal to the radius of the sphere. This is the radius of the sphere. You must remember, girls, this is the condition for a plane to touch a sphere. So now let us come to the problems. Basing on these problems, you are going to do the problems, homework, girls. I gave you here 4 points, girls. You are going to find out equation of the plane passing through, sphere passing through these 4 points. So let us start the required equation of the sphere like this, girls. And all these points are lying on the sphere now. So S passes through A. So substitute the point A in the equation of the sphere. What will you get? See, for x you have to put 4, for y you have to put minus 1, for z you have to put 2. So that you will get an equation UVWD. S is also passing through the point B. So for x you put 0, y you put minus 2, z you put 3, you will get another equation in UVWD. Now, S is also passing through the point C. So, for X you put 1, for Y you put 5, for Z you put minus 1. You will get another equation of the line. Like this is the equation in variables U, V, W, D. And S, the sphere is also passing through the point 1, 5, minus 1. For X you, for X you 2, 0, minus 1. For X you put 2, Y you put 0, Z you put 1. See, you are now finding out the equation of the sphere passing through 4 points, girls. So you take the equation of the sphere like this. Your aim is to find out U, V, W, D. Because there are 4 unknowns, you need to get 4 conditions. To get 4 conditions, he gave you 4 points. So because the sphere is passing through all these 4 points, you will get 4 equations. Okay. Now 4 equations in 4 unknowns, U, V, W, D. You solve them, girls, to get the value U, V, W, D. And after getting the values U, V, W, D, you substitute in the sphere to get the required sphere. This is how you can find out the equation of the sphere passing through 4 points. Okay. Now, how many conditions you need to find out the equation of the sphere? You need 4 conditions. Why 4 conditions? Because there are 4 unknowns, U, V, W, D. Now, second problem. In the first problem, I gave you all 4 points. Now, second problem is what? You are finding out equation of the sphere having center on this line. See, girls, this is a line. A line means intersection of 2 planes. So you are given a line and on which the center of the required sphere lies, and moreover 2 points. See, in the first problem, there were 4 points. So you were able to find out 4 equations and you solved them to get 4 unknowns U, V, W, D and got the equation of the sphere. Now you have only 2 points. Other 2 conditions you can get from this. See, let the line be this. This is the line, girls, which is the intersection of 2 planes, pi 1 and pi 2. Now these are the 2 points A, B. Now what is here? You're going to find out the sphere. You're going to find out the sphere passing through these 2 points and whose center is lying on this line. Okay, so you know how to find out the center of the sphere. If this is the center, you can write this. If this is the sphere, you can write the center as minus U, minus V, minus W. So now this center is lying on this line means it is intersection of 2 planes. So this center lies on the first plane and lies on the second plane. So C lies on both the planes. So this C satisfies the first plane equation and also satisfies the equation of the second plane. So first plane I substitute for C and second plane I substituted. I got 2 conditions. Now you got 2 conditions and also you have 2 more points through which the sphere is passing. So you take that, see, S is passing through this point means you substitute for x2, y minus 1, z minus 1, you get a plane. And also, you get an equation u, v, w, d. And again, S is passing to the point B. So for X, you substitute Z. For Y, you substitute minus 2. For Z, you substitute minus 4. So you will get one more equation in U, V, W, D. So all 4 conditions you got now. So you solve all these 4 equations and to find out U, V, W, D values. Okay. Solve these 4 equations to get U, V, W, D values and substitute in the equation to get the required sphere. So in the first problem, you were given 4 points, girls. Instead of 4 points now, you were given only 2 points and 2 conditions. Altogether, you need 4 conditions or 4 points to find out the equation of the sphere because there are 4 unknowns U, V, W, D. Okay. So you got now the 4 conditions and solving them, you get U, V, W, D values. Substitute them in the sphere, you will get the required sphere. Now coming to the last model, concyclic points. See, 4 points are called concyclic if they lie on the same circle. Okay, 4 points are called concyclic if they lie on the same circle. Okay, so now I gave you 4 points. I'm asking you to check whether they are on the same circle. For this, what you have to do is first you find out the equation of the plane through ABC, girls. Okay, why am I finding out plane, girls? Because you have to get a circle. To get a circle, circle is nothing but intersection of plane and sphere. So first you find out the equation of the plane passing through 3 points. I gave you already one formula, no, girls? So find out the equation of the plane passing through 3 points. And then find out the equation of the sphere passing through OABC. Just now I told you in the first problem how to find out the equation of the sphere passing through 4 points. Like that, you find out equation of the sphere passing through the 4 points OABC. Understood, girls? First, you find out the equation of the plane passing through 3 points ABC. Then you find out the equation of the sphere passing through the 4 points O, A, B, C. Don't touch D. Okay. So So what I did here, equation of the plane passing through 3 points, I'm finding out. How? I found out AB, AC, AD, lines, girls. They are co-initial lines, okay? So I found out the DRs of AB. How will you find the equation of DRs of a line, girls? Difference of x coordinates, difference of y coordinates, difference of z coordinates. Find out DRs of AC. DRs of AC means difference of x coordinates of the points AC, difference of y coordinates of points AC, difference of z coordinates of points AC. DRs of AD. DRs of AD means difference of x coordinates of point A, difference of y coordinates of point A, point y coordinates of point AD, and difference of the z coordinates of points AD. Now you find out the equation of the plane. This is the formula I gave you. Equation of the plane passing through 3 points, girls. You put this and get the equation of the plane. Understood, girls? This we discussed when we were doing the plane problems, girls. Now the question is, 4 points were given and you were asked to show that those 4 points are concyclic, means they are all lying on the same circle. So you need to find out the equation of the circle. To find the equation of the circle, girls, you need to find out the equation of the plane and equation of the sphere. Okay, so equation of the plane passing through 3 points, I'm finding out, and equation of the sphere passing through the 4 points O, A, B, C, you have to find out, like we discussed in problem number 1. Okay, so first you find out the equation of the plane, and this is the equation of the plane. Let us denote it by pi, and you find out the equation of the sphere passing through these 4 points O, A, B, C. Don't touch the point B, girls. Okay, you find out the equation of the plane through ABC. You find the equation of the sphere through OABC. How will you do this? Like I did in the first problem today. So you will get a sphere, you'll get a plane, this sphere, this plane. If they intersect, you get a circle. Okay. So what you have to do before that is, now you have a point D. You check whether the point D satisfies this plane, girls. And also you check whether the point D satisfies the sphere also. Okay, when the point D satisfies the plane and the sphere, then it lies on the circle. S is equal to 0 is equal to pi. So already you have a circle with ABC. Now D is also satisfying the sphere and the plane, means D is also lying on the circle. S is equal to 0. Therefore ABCD are lying on the same circle. S is equal to 0 is equal to pi, where S is equal to 0 is the sphere passing through these 4 points O, A, B, C, and pi is the equation of the plane passing through the points A, B, C. Okay, girls. Now the point D is lying on the sphere. S is equal to 0, and the point D is also lying on the plane. Pi is equal to 0. How will you know that? When D satisfies the equation of the sphere and the equation of the plane. So OABC sphere is containing the point D, and ABC plane is also containing the point D. So D is lying on the circle. S is equal to 0 is equal to pi. So ABCD, all points are lying on the circle. Therefore, they are concyclic. Okay, now you are supposed to do the problems of this model. So one problem on this, one problem on concyclic. Okay, only 2 problems for today. I'll send you the assignment. Any doubts, girls? Any doubts? Any doubts, girls? Okay, I'll close now the session today. I